So on number 1, yes, you have parentheses. There is no exponent on the outside where you have to distribute. There is no exponent. You don't have to distribute anything. So I would look at the inside of each parenthesis and see if you could do anything. So in this parenthesis over here, you can't do anything. You can't cancel out the x's with the z's. There's nothing to do. So let's hold off on that one. But on this parenthesis right here, you could do several things. One would be to reduce 2/8. 2 over 8 reduces down to 1 over 4 if you reduce by 2. What do I mean by reduce by 2? 2 divided by 2 is 1. 8 divided by 2 is 4. So your fraction 2/8 really reduces down to 1/4. Now let's look at the other variables. Well, we have x to the third up here and no x's down here, so there's really nothing to cancel. But we do have 1 y down here and 5 y's up here. So the y down here completely cancels out with one of these, which means there's going to be 4 left over up on top. 4 y's, that is. And the z's, you can't really cancel the z's yet because this is a negative exponent. So what we should do is take that negative exponent and move it up. And that's going to become z to the positive 2 up here. Okay, so I'm going to scratch this out because I already moved it up and I made it z to the positive 2. And let me rewrite what I have in this parenthesis. So what I have left is a 1 up there, a 4 down here, an x to the third, a y to the fourth. I'm running out of space. Let me make some more space here. And a z to the third. And it is over 4, and that's it. Okay? Any questions on that? No? Okay, so hopefully on your paper you have more space than I do. So what I'm going to do is I'm going to take the fraction, this one over here, 4x over z to the third, I'm going to write it right next to it. 4x over z to the third. 4x over z to the third. And we are multiplying, which means I could multiply the top with the top and the bottom with the bottom, or I could start canceling things out already. Because there is a 4 up here and a 4 down here, and we know that 4 divided by 4 is 1, it cancels out. We also have this z to the third up here and the z to the third down there, so we know we could cancel out this z to the third with that z to the third, that would disappear also. So the only thing left on the second fraction, the only thing left is an x. So what we really have is 1x to the third, y to the fourth times x. So when you multiply this x right here with this x to the third, what are we going to get? X to the fourth, right? So our final answer, you could put a 1 if you want to, x to the fourth, y to the fourth. You don't have to put the 1. Could leave it x to the fourth, y to the fourth. But that's the entire answer for number 1. When you multiply both of those together, you just get x to the fourth, y to the fourth. Yay? Okay, I hope you guys understand that. If not, watch the video. Number 2. Copy that one down. So on number 2, there's many ways of doing this. Like, you could distribute the negative 4 into each and every term. I wouldn't do that. The only time I would distribute an outside negative exponent is if you had a lot of negative exponents on the inside. Because if this were a negative 2, a negative 5, a negative 3, a negative 2, when you distribute the negative, then it would change them all to positive, and that would make it easier for me. But because I don't have that many negative exponents, I'm not going to distribute that negative 4. I want to work on the inside of the parentheses. So let me zoom in even further. Let me just look at the inside. What could I cancel out? Well, I have an x squared up on top and an x squared on the bottom. They completely cancel out. There are no more x's. We also have 4 y's on the bottom, and all 4 y's cancel out with 4 of these, and there's going to be 1 y left up on top. Z to the 0, anything to the 0 powers 1, so z to the 0 just cancels out. I mean, you could put a 1 right here, but you don't really need to, because 2 times 1 is still going to be 2, so I'm just going to erase it. And what about that z to the negative 3? I need to grab that z to the negative 3 and move it down. Okay, and that's going to become z to the positive 3. So since I already wrote it down there as z to the positive 3, I want to just scratch it out so I don't get confused. So right now, it'd be a good idea to rewrite my fraction. It's already really getting messy. So let me rewrite it. Parenthesis, I have a 3 on top, a 2 on the bottom. I have a y to the 1 on top, and also a z to the 3 on the bottom. That is ugly. Z to the 3 on the bottom. Z. 2. Okay, I made that uglier. Sorry. But anyway, let's rewrite what we have left. So we still have the outside exponent negative 4, and we also have the outside exponent negative 1/2. Now we should all know that a power to a power you multiply. So to make this a lot easier, let's multiply these guys together, because a negative times a negative is a positive, and 4 times half is what? 2, right? 4 times half, that's like saying 4 divided by 2. So I really have the power of 2 up there. And now it's a question of distributing that 2 to each and every term. So I really have this 2 that's going to go with, let me draw some arrows. 2 is going to go on the 3. There's an invisible 1 on the 3, but now it's going to be 3 squared. There's an invisible 1 on the y, but now it's going to be y squared. There's an invisible 1 on the 2. It's going to be 2 squared. And there's the 3 that you're going to have to multiply, and that'll be 6 down there, z to the 6th. So my final answer is 3 squared, which is 9, y squared over 2 squared, which is 4, z to the 6th power. So there's my final answer. 9y squared over 4z to the 6th. That is my answer for that nasty looking number 2. Let's move on to number 3. I want to pause it, let you copy it down. You guys are going to try to do it. So, what should we start with? What rule do you guys want to apply first? Excellent. Negative exponents, let's move them down and make them positive. So there's going to be a positive m squared down here. This m to the negative 3, you're going to move it up. It's going to become positive. Positive m to the 3 up there. I want to scratch it out because I already moved it. Scratch it out because I already moved it. So now we could look at canceling things out that are on top and bottom, right? So for example, the 3 is up on top. There's a 6 on the bottom. 3 and 6, that reduces. 3, 6 reduces down to what? 1/2. If you reduce by 3, there's a 1 up here and a 2 down here. Okay, but then again, if you notice, there's now a 2 right here and a 2 up there. 2 divided by 2 is 1, so you could actually cancel this top 2 with this bottom 2, and there are no more coefficients. Okay? And then we could also cancel out letters that are on top and bottom that are the same. So, for example, down here, I have an m squared, and I could cancel that out with the m to the 3rd, but you're still going to have an m left over. Well, maybe I shouldn't do that. How about this? It's already getting messy. Let's multiply everything on the top and everything on the bottom just to stay a little bit more organized, yeah? So when I look at the top, I have 1 times, there's nothing there, times n, m to the 3rd. So on the top, I'm going to have n, m to the 3rd. Or writing it in alphabetical order, m to the 3rd n up on top. And on the bottom, I have m times m squared. What's m squared? M times m squared? M to the 3rd, right? Okay, once again, if I go m times m squared, I get the m to the 3rd down here. What else? We also have the n that's left over. So let me bring down that n also. So what could I do now? So you cancel out the m to the third with m to the third and the n to the n, and what's the answer? 0? 1. 1 is the answer.